Okay, let's continue this section, and now we're going to talk about asymptotes of rational functions. And I'm going to talk to you about vertical asymptotes first. You get a vertical asymptote when the function increases or decreases without bound as x approaches some real number. If you look here, you'll see that this graph, as you get closer and closer to that number, that line, that vertical line there is the line x equal 2. And notice that if you follow the graph and get closer and closer and closer to 2, x equal 2, then what's going to happen is you're going to have the graph's going to increase without bounds. Now, another thing you can notice is if you approach the line from the other side here, if you approach the line from the other side, as you approach x equal 2 from the other side, notice how the graph decreases without bound. So that tells us we're going to have a vertical asymptote. Okay, so that's a vertical asymptote. So this graph has a vertical asymptote at x equal 2. Now, a horizontal asymptote is going to occur when x approaches plus or minus infinity and the function approaches a horizontal line. So in other words, as x goes to infinity, the function gets closer and closer and closer to a number, because a horizontal line would be, some number. Like y equal 5 or y equal 6 or y equal 1, something like that. So so right here on this graph, you'll see that as x gets larger and larger and larger, this graph tends to level off at this particular line right here. So that line is actually called a horizontal asymptote. Now also, if x approaches negative infinity, as x goes to negative infinity, if the graph gets closer and closer and closer to some line, without it crossing it here, then that line right there is also a horizontal asymptote. So you can have more than one horizontal asymptote, but most of the graphs I work with, the horizontal asymptote is usually the same in both directions. Now, on this third graph, I have a slant asymptote. Okay, and I didn't put it on there yet because I wanted you to see what the graph looks like. And actually, there's a vertical asymptote right here, and that vertical line that you see should not be there. The graph is just this piece and this piece. Okay, so let me go ahead and show you what the slant asymptote looks like. So this line, a slanted line, would be what we call the slant asymptote for that graph. And the reason is because this time as x goes to infinity, instead of approaching a horizontal line, the graph approaches a slanted line. And same thing if you go to negative infinity. As x approaches negative infinity, the graph approaches a slanted line. And so that's the difference between horizontal, vertical, and slant asymptotes. And let me show you here, this graph has a couple of vertical asymptotes as well. Try to highlight them for you. Okay, so this third graph not only has a slant asymptote, but it also has vertical asymptotes. The first graph has horizontal asymptote and vertical asymptote. The second graph only has horizontal asymptotes. One thing that you can't have when graphing rational functions, you can't have a slant asymptote and a horizontal asymptote, because those asymptotes come from letting x go to infinity or letting x go to negative infinity, And you know, if the graph's going to have a slant asymptote, it's not going to have a horizontal asymptote. Okay, now let's talk about how to find these asymptotes. The vertical asymptotes are the easiest to find because all you have to do to find vertical asymptotes is find the values that make the denominator equal 0. So notice here, this function 1 over x, notice that if x equals 0, the denominator would be 0. So this has a vertical asymptote at x equals 0. And this, if you ask what makes x cubed minus 8 equals 0, well, if x is 2, you would get 0 in the denominator. So you must have a vertical asymptote at x equals 2. And here, remember, this factors into x minus 5x plus 5. So the numbers 5 and negative 5 make the denominator equal 0, and therefore the vertical asymptotes would be x equal negative 5 and x equal 5. Now, let's go ahead. Let me show you these on the graph, and I'll show you the vertical asymptotes as we look at them on the graph. Okay, so here's the graph of 1 over x. Okay, now the graph of 1 over x, it has, remember I said it has a vertical asymptote. Can you see it there? I've got it black. So there's the vertical asymptote, and that's the line x equals 0. Okay. It also has a horizontal asymptote. We'll come back to that later. All right. So let's move on to the next graph. This graph here looks like this. Okay. Now I did not mean for that to be dotted. Hang on just a second here. Okay. So that graph looks like this. So it's kind of funny looking here, but if you plot x equal 2, you can see that it has a vertical asymptote. Now the graph never actually touches that line, it just gets infinitely close to it. So you can see the vertical asymptote there. Let me change the color of the graph, and that might help us a little bit. There. Now let me do it again. There you go. Now you can see the graph has a vertical asymptote at x equal 2. And then we have this graph. Okay, now remember this graph had vertical asymptotes at x equal 5. See, there's the vertical asymptote at x equal 5. And then it has the vertical asymptote at x equal negative 5. Okay, so that gives you a picture. Now, of course, these asymptotes are not actually part of the graph. They're just information about the graph. To identify horizontal asymptotes, what you have to do is look at the degree of the numerator. And I'll let you read this as I explain it. When you have a function, if the degree of the numerator, remember this has a degree 1 and this has a degree 2. So if the degree of the numerator is 1 less than the degree of the denominator, then your horizontal asymptote will be the line y equals 0, which is the x-axis. Now, if the degree of the numerator is equal to the degree of the denominator, then your horizontal asymptote will be the line y equals the coefficient of the lead variable, the lead coefficient over the lead coefficient. So since x squared is the highest degree, then on the top and bottom, then basically what we're going to have here, we take the coefficient of 2 over the coefficient 3, and so 2/3 is the horizontal asymptote. Now, if the degree of the top is greater than the degree of the bottom, you actually don't have any horizontal asymptote. Here you have the degree of the top is 3 and the degree of the bottom is 2. So you have no horizontal asymptote for that one. Okay, so this is the graph of the first one that I just showed you, 2x minus 1 over 3x squared plus 2. And remember, we said that its horizontal asymptote was the y equals 0, which is the x-axis. And let me show you that. And you can see that as x gets larger and larger and larger, the graph gets closer and closer and closer to the x-axis, or the line y equals 0. And also in this direction, as x gets smaller and smaller and smaller, in this direction it gets closer and closer and closer to the x-axis, or the line y equals 0. So y equals 0 is certainly the horizontal asymptote for that graph. Okay, now the second graph, remember we got we found that this graph has a horizontal asymptote of y equal 2/3. And watch what happens if I graph y equal 2/3. Okay, so this dotted line is the line y equal 2/3. And notice here, as x gets large, the graph approaches that line, and as x gets very, very small, in other words, in the negative direction, the graph approaches that line. Okay, and then so y equal 2/3 is the horizontal asymptote of that one. And then the next one, notice for this one, notice that the graph just continues to increase as x gets large. The y values continue to get large, and in both directions, as x gets very, very small, the y values continue to get very, very small. So this one has no horizontal asymptote. So you see that little trick I showed you work. The degree of the numerator is less than the degree of the denominator. The horizontal asymptote is y equals 0. The degree of the numerator is equal to the degree of the denominator. Horizontal asymptote is y equal to the ratio of the lead coefficients. And if the degree of the numerator is larger than the degree of the denominator, you're not going to have any horizontal asymptotes. I'm not going to spend a lot of time on slant asymptotes, but I will tell you this, that the only time slant asymptotes occur is when the degree of the numerator is 1 greater than the degree of the denominator. So here the degree is 3, here the degree is 2, 3 is 1 more than 2, so this graph would have a slant asymptote. Here, the same thing on this one, the degree is 2, here the degree is 1, the degree of this is 1 more than the degree of this, so this graph would have a slant asymptote. Okay, so looking at this one, remember the denominator would be 0 at -5 or +5, so you're going to get, if you look over here, you'll get a vertical asymptote at x equals -5 and x equals +5. The degree of the top is less than the degree of the bottom, so you're going to get a horizontal asymptote of y equals 0, which is the x-axis. Look at the next one. You're going to get a vertical asymptote x equal -2, because that makes the bottom 0. So I don't have that drawn, but I can easily put it on there for you. X equal -2 would be about right there, and so that's your vertical asymptote. And now you get a horizontal asymptote, a slant asymptote here. This is the line y equal 3x minus 6. I'm not going to go over this with you, but I will tell you that if you long divide the bottom into the top, you'll get 3x minus 6 with a remainder. And I didn't write the remainder down, but you'll get 3x minus 6 with a remainder. And that's how you find the vertical asymptote, the slant asymptote. It's just the line y equal 3x minus 6. So if you need to know how to do that, then you might want to do a little bit more digging on actually determining what how to determine slant asymptotes. But that black dotted line is the slant asymptote for this graph. And then lastly, this graph, there's no way that 3x squared plus 2 could equal 0, so there's no vertical asymptotes. And then also notice that the degree of the top is equal to the degree of the bottom, so you have a horizontal asymptote, and the horizontal asymptote is the coefficient of the ratio of these two coefficients, 2/3. So y equal 2/3 is the horizontal asymptote, and you can see here that I got the graph, and this dotted line represents the graph of y equal 2/3. So basically with rational functions, you can have 3 types of asymptotes. You can have vertical asymptotes, horizontal asymptotes, and you can have slant asymptotes. And that is going to end chapter 2 on functions and this section on rational functions. Have a good day.